Welcome back, students. Today we're going to continue working with quadratic equations. Just as a reminder, y equals ax squared plus bx plus c. This is called the standard form of a quadratic. And it was nice back when we can y equals, type it into a calculator, get your graph, which will always be a parabola that either opens up or down. It was also nice for solving by either factoring or by using the quadratic formula especially, because you just got your a, your b, and your c by looking at your coefficients and your constant. But when it comes to graphing the quadratic equation in standard form, really the only thing that I can get from being in standard form, right, just by looking at it, is going to be if the graph opens up or down. So if A is positive, the graph will open up. If A is negative, the graph will open down. The other item is the C, the plus C at the end. That will always tell you what the y-intercept is. But other than that, having an equation in standard form, if you're trying to graph it or trying to get a sketch of the graph, if you don't have a graphing calculator available, then Vertex form is actually going to be the better form to use. So Vertex form, remember, is y equals a, and then in parentheses it'll be x, and then either plus or minus a number, which will represent the x coordinate of the vertex, squared, and then plus or minus a constant at the end, but we use k to represent this one, and this will represent the y coordinate of the vertex. So the reason why it's called vertex form is because you can get the vertex by just looking at this equation. You'll take the opposite sign of whatever number is being added or subtracted from x, and then you'll just take whatever number you have at the end, put it together as an ordered pair, and you have your vertex. So what we're going to focus on today, we'll do a little review and some warm-ups, but what we're going to focus on today is taking an equation that is written in standard form and converting it into vertex form. All right, because again, the nice thing about having an equation in vertex form, such as this one, is I can automatically, by looking at this equation, know where the vertex is. It's going to be opposite whatever is inside of the parentheses with x. So this is a plus 1, so it'll be an opposite, which will be a minus 1. And then whatever number is at the very end, which is a negative 4. So the vertex, which is either the highest or lowest point on the graph, the maximum or the minimum point, the vertex would be at negative 1, negative 4. That would also tell me that there is axis of symmetry at x equals negative 1. I can also use vertex form. The first number, a, if it's positive, it means the graph opens up. If it's negative, it means that parabola opens down. So since this is a positive 2, it means that this graph opens up. A also tells me the shape of the graph. If the absolute value of A is equal to 1, then that graph is normal. If the absolute value of A is greater than 1, then that means that your graph is going to be narrow. And if your absolute value of A is less than 1, then that means that the graph is going to be wide. All right, so this, since we have a 2 right here, that means that this graph, the shape of it, is going to be more narrow than the parent graph of just y equals x squared. All right, another example right here. Vertex, that's what I'll get first. I take the opposite of whatever number is inside the parentheses with x, so this is going to be a positive 3. And then at the end, we have a positive 5. So this vertex would be located at 3, 5. It's either the maximum point or the minimum point of our graph. And so, since our graph opens down, we know that it would be the maximum. This would be the highest point that our parabola reaches. And again, the reason why I said that this opens down is because in front of the parentheses, we have a negative 1/4, and that negative means the graph is opening down. Since 1/4, the absolute value of negative 1/4 is 1/4, that number is less than 1. That means that this graph would be more wide than your parent graph of y equals x squared. All right, so vertex form is really handy, especially if you go on past Algebra 2, you go to pre-cal or calculus, when a big portion of that material is going to be to sketch a graph, and they might take that calculator away from you. So how can you sketch that graph? How can you get this mental image of what is that vertex, or what is that parabola looking like? Well, you can get it from having that equation given to you in vertex form. So what we're going to focus on today is taking these equations from standard form and writing them into Vertex form. So before we get into that process called completing the square, let's just make sure that we're really comfortable with expanding and factoring, which are inverse operations. They'll undo each other. So if you ever given a binomial and it's squared, what that means is to square something is to take it and multiply it by itself. So I'm going to take my binomial, x plus 3, and I'm going to multiply it by x plus 3. So what this calls for is repeated distribution. I need to take x and multiply that to my second polynomial. So I'm going to take x and multiply it by x plus 3. And then I need to take positive 3 and distribute that into the second polynomial, which was, again, x plus 3. All right, so the distributive property, I'll take x times x, which will give me x squared. I'll take x times positive 3, which will give me positive 3x. And then I'll take positive 3 and distribute that in. So positive 3 times x is positive 3x. And then positive 3 times positive 3, which is positive 9. Combining like terms, and that will give me x squared plus 6x plus 9. All right, so x plus 3, that quantity squared, is equivalent to x squared plus 6x plus 9. X plus 3 quantity squared is in factored form, and x squared plus 6x plus 9 is in expanded form. That is just the given trinomial. All right, so over here I have x squared plus 6x plus 9. You might not recognize it right away. So what you would probably do is go through the entire steps of factoring. So it's in order. There is no GCF. There are 1, 2, 3 terms. So you do your A, B, C's to factor. And you try to come up with two numbers that multiply together to give you your A times C. So 1 times 9, which is 9. And combine to your middle number, so which would mean add up to the middle number, which in our case is 6. So two numbers that multiply to 9 and add to 6 are going to be 3 and 3. So it's called split the middle because you keep the first term the same, but you split the middle term, and instead of writing it as 6x, you write it as 3x plus 3x, and then you still have the plus 9, which now calls for factor by grouping. So x squared plus 3x has an x in common, and we're left with x plus 3. So back here, we need to have x plus 3, and we can factor out a positive 3. So this would give us x plus 3 from what was the same inside the parentheses, and what we're distributing by, what we factored out, which is the x and the plus 3, which means we have the same quantity twice, so we could write it as x plus 3 squared. All right, let's try another one. If we were given this trinomial, trying to write it so it's something squared, let's see if that would be able to work. So it's in order. There is no GCF. There are 1, 2, 3 terms. So what we try to do is do the ABC, split the middle. So are there two numbers that multiply to 10 and combine to 6? So numbers that multiply to 10 would be 1 and 10, but that adds to 11, so that doesn't work. 2 and 5, but that adds to 7, so that doesn't work. So this one would be prime. What we're going to do today is we are going to make it. We are going to force these equations to have this term where we have a quantity squared. We are going to force it upon it. So even though right now x squared plus 6x plus 10 cannot be written like x plus 3 quantity squared, by doing this process of completing the square, we will make it so it looks like this. And that is called completing the square. So you can read through. I'll attach to the Google Classroom the filled in notes for today, so you can read through the steps. But what I'm going to do right now is I'm just going to go through some basic examples with you. So here's how you complete the square. Our goal is to take a trinomial, and we're trying to figure out what does that constant need to be in order to make it. So this trinomial factors to be some quantity squared. All right, so we know we have x squared, so we know that the first term will always be x, but what are we going to have to add here? And so what does that constant have to be up here? Well, to figure this out, in order to get this to factor down, what we're trying to do is to come up with two numbers that combine to 10x. Well, the x part is already taken care of, so we're now worried about the coefficient of 10. So what two numbers, if you add them together, are the same that add to 10? So all we need to do really is divide by 2. So if we take 10 and divide it by 2, we get 5. It's positive, so I'm going to put a plus 5. What is 5 plus 5? Well, it's positive 10. All right, so now we've figured out what this value needs to be. So if we were to take x plus 5 and multiply it by x plus 5, this would give us x squared plus 10x, and then 5 times 5 would give us 25. So that means that this value right here, in order for this trinomial to factor down to be this binomial squared, this value right here would have to be positive 25. How did I figure that out? Well, to get this last number, you're always taking this number times itself. So what we're doing is we're taking that number and we're squaring it. So if I take positive 5 times positive 5, it gives me positive 25. Let's do another example. For this next example, I have x squared minus 18x, and then I need to figure out what this value needs to be for this trinomial to be able to factor down into a quantity squared. So I know this first term is going to be x, as it always will be, but what's this number going to have to be? Okay, well, again, in order to get that middle term, if you were to FOIL this out, or if you were to multiply this out, these numbers are going to have to add together to give you negative 18, and we want them to be the same number because we need to be able to write it as this quantity written twice, which means it has to be the same. So what number plus itself gives us negative 18? Well, if we divide it by 2, we come up with negative 9. So negative 9 plus negative 9 is negative 18. All right, so if you need to, off to the side, you could then figure out, well, what would this expanded form be? So x minus 9 times x minus 9, x times x would give me x squared. X times negative 9 is negative 9x. I have 2 of those. That would give me a negative 18x. And then the last term is always going to be negative 9 times negative 9. This number times itself. So all I need to do is square this, and negative 9 times negative 9 is positive 81. Let's do another example. Here we have x squared plus 4x, and then we'll figure out what that term needs to be. So if we were to write this as a quantity squared, this will always be x. What number is this? Well, it's always divided by 2. So 4 divided by 2 is positive 2. Now we'll figure that last term by squaring what we just wrote. So positive 2 times positive 2 would be positive 4. And you can double check these. You can pause the video. You can take the trinomial and factor it down, and you should get this. Or you can take this factored form and expand it, and you should get this trinomial. These are equivalent expressions. It's just one's written out more in the standard form, and one's written out in this Vertex form. Let's do one more example. Pause the video and see if you can get it on your own before I tell you. All right, so for this one, we have x squared minus 6x. So it's going to be some quantity squared. It's going to be x plus or minus something. And what we're going to have is negative 6 divided by 2, which is negative 3. So negative 3 times negative 3, when I go back to square it to complete this trinomial, I get positive 9. So again, my trinomial, my unfactored form, my expanded form is x squared minus 6x plus 9. But if I were to put that into factored form, I would be able to factor it down to be x minus 3 quantity squared. All right, so now what we're going to do is that same concept, okay, only this time, notice up here we had blanks. We were trying to figure out that value to make it so it factored. Now this time, we already have a number right there. So what we're going to have to do is we are going to have to do what we were doing up above, okay? But then since there's already a number right there, what we're going to need to do is we're going to need to balance our equation. We can't just add a number into an equation without balancing it, okay? Whatever we do to one side, we have to do to the other. Or if we do something on one side, if we take it away or if we do the opposite, then that would balance our equation. So what we have here is we have the equation y equals x squared plus 4x plus 3. If I were to try to factor this down, come up with two numbers that multiply to 3 and add to 4, my two numbers that multiply to 3 and add to 4 are 3 and 1. So it would be able to factor, but my goal is to try to write it as something, that quantity times itself. And 3 and 1 obviously are not the same number, which means that this is not going to work. I can't just factor this down. So here's what I'm going to need to do. I'm going to rewrite this equation, y equals x squared plus 4x. I'm going to go ahead and put my blank in, just like I had up above. But then I need to write my plus 3, and then I'm going to put another blank. These two blanks are going to balance each other. So what that means is if I put a plus 5 right here, I'd have to put a minus 5 because their net value has to make 0. So if I put a minus 2 right here, I'd have to put a plus 2 over here because negative 2 plus 2, those cancel out. Those make 0. So then it's really like I'm not doing anything. I'm just changing what it looks like. I'm not actually changing the value. All right, so what we're going to do is we're going to ignore the plus 3 part right now. So I'm going to put a dividing bar just so I can't really cover it up. But what I would do is on my paper, I'd put my hands over the plus 3 in this second space, and I would only focus on this. So x squared plus 4x and then a blank. We might have even done that one up above. We did, right here. Okay, so we should be able to do this. X squared plus 4x, I know my first term will always be x, and then the 4x, I need to come up with a number that if I combine it with itself, it's going to give me 4, and that's going to be positive 2. I can get that by taking 4 divided by 2. So 4 divided by 2 is 2. So that means this value that would get added in right here would be a positive 4, because 2 times 2 is going to give me 4. But I can't simply add this into an equation. I need to balance it. So if I'm going to put a plus 4 right here, then that means that back here, I'm going to need to put a minus 4. So this trinomial factors to be x plus 2 quantity squared. This plus 3 minus 4 is kind of the leftovers. So what we need to do is put the leftovers at the end. So positive 3 minus 4 would give us negative 1. And now we have our equation in vertex form. We have our a out in front, which is a positive 1. So that means that this graph, since it's positive out in front, means the graph opens up. Since it's a 1, it means that the shape of this graph is going to be normal. And the vertex, take the opposite of what's inside parentheses, which is negative 2, and then the number at the end, which is negative 1. The vertex, all right, the minimum point for this graph is located at negative 2, negative 1. Let's do another example. So what I'm going to do is I'm going to rewrite this. I have y equals x squared minus 2x. I'm going to put a blank so I can figure out how is this trinomial going to factor down to be some quantity squared. But then I have this plus 4, and then I'll need to put another blank to balance my equation. All right, so let's do the completing the square part first. So x squared, so that means that this is going to be x because only x times x is going to give us x squared. This number needs to be half of this number. So negative 2 divided by 2 is going to give me negative 1. The reason why I know that is because negative 1 plus itself gives me the negative 2, which is what I need. So here is going to be the factored form of this trinomial. So I need to figure out, well, what did that constant need to be? Well, negative 1 times negative 1 is positive 1. So this trinomial factors to be x minus 1 quantity squared. But we didn't just have this trinomial. We also had this plus 4. So what we need to do, we can't just put plus 4 here. We need to balance our equation. So if we're going to add in this positive 1, what that means is over here we need to subtract 1 because it's positive 1 minus 1 that makes 0. So 4 minus 1, okay, because it's that trinomial that factors to be x minus 1 quantity squared. So we have this leftovers of 4 minus 1. So 4 minus 1 would give us a positive 3. So right here we have our vertex form. Out in front, we don't have a number, so that means that a is 1, which means that this graph opens up. The shape of this graph is normal. And then the vertex would be at positive 1, positive 3. Let's go up and do a couple more examples before we start getting numbers in front of our x squared term. So when a is 1, let's do some more examples of those. So what we'll do is we'll rewrite. We'll have x squared minus 6x. We'll put a blank here to figure out how can this trinomial factor. And then the leftover of minus 1 and then another blank in order to balance. So this factored form of this perfect square trinomial is we're going to make this be x. And then in order to add to negative 6, the same number twice, we're going to divide that by 2. And negative 6 divided by 2 is negative 3. So if I were to expand this, my last term would be negative 3 times negative 3, which is positive 9. So this trinomial factors to be x minus 3 quantities squared. But I didn't just have that trinomial. I had a minus 1 at the end, and I didn't even have this plus 9. So what I'm going to need to do is balance this. If I put a plus 9 in right here to make it so it factors, that means that back here I'm going to have to put a minus 9. Because adding 9 and subtracting 9 cancel out. It means I'm really not doing anything. So that means that back here, my leftovers is going to give me negative 1 minus 9, which is going to give me a negative 10. So this tells me, since I don't have that number out in front, which would be a positive 1, it tells me that this graph is going to open up. Since it's positive, the shape of the graph is normal, since it's just that positive 1, and the vertex would be at positive 3, negative 10. Let's do another example. So we have y equals, we have x squared minus 4x. We'll put in a blank, and then we'll put the plus 4. We're going to make this trinomial factor to be some quantity squared. So x times x is what's going to give us x squared. But now we need to figure out what number added to itself is going to give us negative 4. So what number plus itself gives us negative 4? And that's negative 2. If I take negative 4 divided by 2, that will give me this number. So then if I were to expand this, negative 2 times negative 2 gives me positive 4. But I don't have this positive 4 right here. Well, actually, I did. But I didn't know that ahead of time because I didn't try to factor. So if I'm just going through this blindly and going through the process of completing the square, what I would think to myself is if I put a plus 4 on this blank, I'd have to put a minus 4 on this blank. And then positive 4 minus 4 would give me a 0 at the end. So you can put that plus 0 right there. You don't have to. Okay. What this is telling me is that this trinomial right here was already ready to be factored and put into this vertex form. So my number out in front was a 1, which once again tells me the graph opens up. The shape of this graph is normal. And the vertex would be located at positive 2, and then no number back here, which would be a 0. So positive 2, comma 0. So this is telling me a few things. Since this right here would be an x-intercept, this is telling me I'd have a double root. And this is telling me that when I were to graph this, my vertex is located on the x-axis, so I'd only have one solution. There would only be one x-intercept, so it would be a double root. So a lot can be found by having your equation given to you in vertex form, which is why we're practicing putting it into vertex form today. So far, all of these examples, we have had up and normal for all of these because we've only had a positive 1 out in front of our x squared term. Now we're going to get into the cases where we don't just have a positive 1. So these are going to be a little bit harder, which is why I've saved them for last. So what we're going to need to do is we are going to still go ahead and put our blank. We're going to put parentheses around the trinomial that's going to factor down to give us this quantity squared. But then what we need to do is we're going to always factor out that a. We're going to factor out that term from just the trinomial that's going to factor down to be this quadratic or this binomial squared. So what's in front of x squared? Well, it's a 2. So what we're going to do is we're going to take the 2 and move it out in front. And then in parentheses, we're left with x squared minus 6x and then a blank. All right, so writing this in factored form, we still need to have this 2 out in front of our parentheses, but then we're going to take this parentheses, which is our trinomial, and we're going to put it as a binomial squared. So what times what gives us x squared? That's x. What two numbers add to negative 6 if we add it to itself? So that's going to be negative 3. So what's this number going to have to be? Well, this number is going to be negative 3 times negative 3, which is a positive 9. All right, now this is the tricky part. Okay, if I add something in, which is what I just did up here, then I'm going to have to cancel it out back here. All right, well, this number itself is a positive 9, so I'd think I would just put a minus 9 right here, but it's not just a positive 9. Why is it not just a positive 9? Well, because it's sitting inside parentheses, and out in front of those parentheses is a 2. So that means that if I were to distribute 2 times positive 9, this is actually a positive 18. So if I need to balance this equation, if I'm putting a plus 18 here, I need to put a minus 18. So I'll need to put a minus 18. And I didn't have any other leftovers, so I'm just going to have the minus 18 there at the end. All right, so all of this together makes my vertex form. My A is positive, which means my graph does open up, but now it's a 2, and 2 is more than 1, which means that this shape is going to be narrow. And the vertex would be located at positive 3, negative 18. Another example. So here we have y equals, I'm going to go ahead and rewrite this a little bit. I'm going to have negative 4x squared minus 24x. I'm going to put in my blank, and then I'm going to put my minus 15 and then my other blank. Now I'm going to group my trinomial together, and I'm going to go ahead and down here write my binomial squared. Now, in order for this to become an x, it means that this negative 4 needs to get factored out. So I'm going to put in another step right here. We're kind of doing multiple steps simultaneously, so please make sure that you're showing your work and that you're leaving enough room to be able to go fill in some parts and then go back to fill in the rest of the steps. So what I'm going to do now is from this trinomial, factor out the negative 4. So this is going to become a negative 4, and then I'm going to have x squared plus 6x, and then the parentheses, and then I still have my minus 15, and then I still have my other blank. So the negative 4 still needs to be in front of the parentheses. X times x is what gives me x squared, but what number plus itself gives me positive 6? Well, that would be positive 3. So positive 3 times positive 3 would make this be positive 9, but it's not really just a positive 9 because there's this negative 4 out in front. So negative 4 times 9 is really a negative 36. So the opposite of a minus 36 would be a plus 36 back here. So I'm going to have a plus 36. So it's this trinomial that factors to be x plus 3 quantity squared. So our leftovers are a minus 15 plus 36, which would give us a plus 21. So here would be our final answer. And here, let me show you a good way, if you do have access to a graphing calculator, a good way to check to make sure that you're right. Graph them in both ways. Graph the standard form. So this was negative 4x squared minus 24x and then minus 15. There's the standard form. Graph your vertex form as well. These two parabolas should be identical. All we did was took it from one form to another. So what I can do is I can make sure when I graph them both, if I take one away and then put it back on, are they right on top of each other? Yes, they are. So because they're the same graph, that tells me I did it right. And then now I can just use my vertex form in order to answer these questions about my quadratic, my parabola, some transformations. So the vertex would be at negative 3, positive 21, and that can be confirmed by looking at my parabola that's been graphed. I click on it right there, negative 3, positive 21. My direction, the graph opens down. And the shape of this graph, I have a negative 4 out in front, which the absolute value of that is more than 1, which means that this graph is going to be more narrow than that parent graph. So again, I could fill all of this out without using my graphing calculator because I had now put it into vertex form. All the standard form was good for was telling me that my negative 15, I have a y-intercept down at negative 15, and I can verify that right here. Let's do a few more examples. So here what I'll do first is rewrite it to be y equals negative 3x squared plus 12x with a blank, and then a minus 10 with another blank to balance. I'll put parentheses around my trinomial, and then I'm going to factor out the a. So this is negative 3, and then I'm left with x squared, and then minus 4x, and then a blank, and then I still have my minus 10 and another blank. So I'm going to have y equals negative 3. I'll make my binomial squared. X times x is what gives me x squared. What number plus itself gives me negative 4? And that's negative 2. What is negative 2 times negative 2? Well, that's positive 4. But this isn't just positive 4. There's a negative 3 out in front, which makes this really a negative 12. So if this is a negative 12, to balance, I'd need to have a positive 12 back here. Negative 10 plus 12 is going to give me positive 2. Whoops, I shouldn't do that yet. Got ahead of myself. So this is still a plus 12. Here, I just need to combine those. Negative 10 plus 12 is going to give me the positive 2. So here is my equation in vertex form. That A is negative, which means that this graph opens down. Negative 3, the absolute value of that is more than 1, which makes that this graph is going to be narrow, and its vertex would be located at positive 2, positive 2. All right, last example. We have y equals negative x squared plus 8x. We'll put our blank, and then we have minus 7, and we'll have another blank. I'm going to group up my trinomial. And since I have an a that's not just positive 1, I need to factor. So I'm going to factor out just the negative 1. And that's going to leave me with x squared, and then minus 8x, and then my blank, and then minus 7, and then my other blank. So I'll have y equals negative 1. I'll make my binomial squared. What times what gives me x squared? Well, that's just x times x. What number plus itself gives me negative 8? And that's going to be negative 4. What is negative 4 times negative 4? Well, that's positive 16. But this really isn't just positive 16 because there's a negative 1 out in front, which means that this is really negative 16. So if I need to balance this negative 16, what that means is I'm going to have to put a plus 16 over here. So this is going to have to be a plus 16 back here. So the trinomial factors to be x minus 4 quantity squared. My leftovers are negative 7 plus 16, which is going to give me a positive 9. So here would be my final answer. Again, to verify this, I could graph it both in standard and vertex form. But the vertex form, without even looking at a graph, I know the vertex would be located at 4, 9. I know that this graph, since we have an a of negative 1, I know that this graph opens down. But I know that the shape is normal. It hasn't been stretched at all. Okay, the shape is normal because the absolute value of negative 1 is 1, okay, which means that my shape remains normal. All right, so there you have it. Vertex form, standard form, both very important when it comes to quadratics. However, if we were to be able to tell quadratic transformations without using a graphing calculator, vertex form is better. It really is. It is better for being able to tell you about quadratic transformations. And this is why we use the process completing the square in order to go from standard form into vertex form.